Hey everybody, here's our third tutorial of the semester, and we're going to look at a series of topics today. The image you see here is the summer camp I direct in Pennsylvania in the winter, and I was there over the weekend and it was a beautiful sunset. So let's begin by just listing the things that we're going to be working on today. We're going to begin talking about projects. And projects are a way of packaging up multiple Subpatchers, audio files, image files, 3D object files. Everything that goes into a project gets put into the same folder. So rather than copying, compressed, and pasting into emails, now that projects are getting more complicated, we're going to actually package them up as projects and exchange them as compressed zip files of the project folder. So we'll look at how to do that. We're going to look at materials briefly. We're going to look at lights. We're going to look at the poly Tilde object, which is a way of spawning multiple objects. And then we're going to look at a few more new objects: counter, scale, Uzi, and tempo. So first, let's take a look at how to create a project. Well, so far we've been going File, New Patcher. From now on, we're going to go File, New Project. And this will prompt us to create a new project, and the default location for saving the project will be the projects folder inside the Max 7 folder. You can save it wherever you want. This is tutorial 3 project. And what that gives us is it gives us this new project window, which we haven't seen before, and we can add files to it, either new files or pre-existing files. So for instance, if I save this, save as tutorial 3 notes, I can then add it here with the plus. I can add an existing file to this project, tutorial 3 notes, open, and now this max patch is part of this project. So whenever I open the project, I'll have access to this patch. I could also create a new file within the project. I'll call it tutorial 3 main patch. Save it, and it automatically becomes part of the project. And when I open it, it's an empty patcher window. So as per usual, I'm going to begin by pasting in our starter that I gave you on the first day of class. And or if you're following this from Facebook or YouTube, I've attached this little piece of Max to the Facebook post. And this gives us our starting place. Notice I've added one thing here at FSAA1. This is just an aliasing flag, anti-aliasing flag that's going to make graphics look smoother. You can add that to your basic setup if you're still using the one I sent originally at the beginning of the semester. And we still haven't actually talked about auto patter and patter storage and store 1 and store 2, but we will get to those soon. That's just not on the list for today. So this is the way to create a project, and then anything you add now, sound files, image files, they all go in the project rather than having to attach them, put them in the same folder and attach them to the email as we've been doing previously. They can go in the project, and then you just compress the project and send the whole project file attached to an email. So let's look at our next topic, I'll open up these notes again. Our next topic is going to be materials. So materials affect the look and feel of our objects. Right now we're just creating very simple plain objects. I'm going to name my world tut3, bring that window over. So when I create a jit.gl.grid shape, let's zoom in a bit here and set my font to Monaco and the whole patch. Even when I turn lighting enable, and smooth shading on, I'm still getting kind of a plain clay looking object, if you will. And also I'm getting the sort of low resolution flattened edges because I haven't increased the dimensionality. I'll crank that up to 100 by 100. Now I'm getting it's a nice smooth sphere, but it's not an interesting surface. The way the virtual light reflects off of the surface, it's like clay. What I can do is I can add a jit.gl.material object, and simply by connecting that to my grid shape, I get a much more reflective surface, a surface that has a nicer quality to it. Again, here it is without, and here it is with. The way in which the light is reflected is handled by what's called a shader in jit.gl.material, and it gives us a more refined look, and it's also a look that we can modify in several ways. I'm going to change this object into a cube. And for right now, we'll just look at one simple use of the jit.gl.material, which is to add a diffuse map, which basically means to put an image onto the object. So first of all, I just want to point out one thing which has caused some confusion. Note how my jit.gl.camera is not connected to anything. It doesn't need to be. Creating the jit.gl.camera object places a camera in the virtual world. And since we have one screen, we only need one camera, and that camera is at a location and is looking at the objects in our world. We're going to take a closer look at how to make it look at different things in just a moment. But let me finish up with the jit.gl.material. I'm connecting it, binding it to this particular jit.gl.grid shape. And then I can very simply take an image file, any image file. For instance, I'm dragging in this image of the surface of Antarctica, actually, connecting it to the leftmost inlet of jit.gl.material, hooking a button up to it, and pressing that button, and the texture gets mapped onto the object. Stick an attrui on here so I can get a little rotation. And we can see that this image has been very nicely mapped onto the surface of the cube. And you can see the material itself has more reflectivity, more shininess than our sort of plain materialless object did. So this is a quite nice thing to begin doing with your objects, is to give them a material. So let's take a look for a moment before we move on to lighting at the camera, because there's a couple more things that we can do with the camera that we haven't talked about yet. Let's create two of these objects. Each object needs its own jit.gl.material, but I can send them both the same texture if I choose to. They're both textured in the same way. So here are my two cubes. One is rotated, the other is unrotated. And we can move them apart in space. Zoom my camera out a bit, and I can actually rotate them together. So my camera, so far what we've been doing is we've been moving the camera using the jit.anim.drive object and flying the camera around using messages. So move to 0, 0, 10 means move it 10 meters away in 3 seconds. So we fly out to 10 meters away, or we can move quite close, move to 3 meters away in 1 second. But if we move to the left or the right, for instance, if I move 5 meters to the right, I'm no longer looking at the center of my scene. I'm dollying the camera over to the right. Now I'm dollying it to the left. And I have another message I can send directly to the camera. This is not to the anim.drive, and this is a mistake you need to watch out for. I can tell the camera not just where to be, not just its position, but I can also tell it what to look at with the look at message. Look at 0, 0, 0. So if I fly my camera in and then dolly my camera to the right, I'm no longer looking at the center of my world. So I can say, look at the center of my world, and that turns the camera. So now I'm looking at the center of the world. Look at 0, 0, 0. Or zoom back out, look at 0, 0, 0, and I can look around without moving the camera. For instance, I can put an attrui here and modify my look at. Looking left and right, looking up and down. We'd call this panning. I'm panning the camera. I'm tilting the camera. I'm not moving the physical position of the camera. I'm just you could say I'm not moving the tripod. This moves the tripod. I'm just reorienting the camera using the tripod head. And there's one more message I want to show you, which is locklook. So if I want the camera to always remain looking at a particular spot, let's say the right-hand cube, which happens to be located at 200, I can say look at 200. That means look at the right-hand cube. And then I can also say lock look 1. And 1, as we know, means yes or true. So do lock look. Once I do lock look, wherever I move my camera, it will stay looking at the look at position. And then if I ever want to turn that off, I can say lock look 0, and now the look is no longer locked to that location. I need to click this again if I want it to go back to looking at that. So one thing that you'll very commonly see, and we haven't talked about this, but you can put two messages into the same message box by separating them with a comma, and they'll be sent sequentially. So the message look at 200, comma, lock look 1 means first look at 200, the right-hand cube, then lock the look position so that wherever the camera moves, it's still looking at that same position. So that's a very handy addition to jit.gl.camera, and just a quick introduction to jit.gl.material. One other thing you should know about jit.gl.material is once you are using a jit.gl.material, it controls color, because color is a quality of the material of the object. So your gl.color message no longer goes to your grid shape, it now goes to your jit.gl.material. So make a note of that. So what you should do right now is really stop the tutorial and work back through all of this stuff, if you haven't been doing it with me as the tutorial's been going, to make sure that you're absolutely clear about everything we have so far. So take a pause right now, go back through that material, and then come back for the next section where we'll talk about lighting. So right now I have a default lighting situation. The light is just an ambient light that comes from the upper right of my scene, and it's just enough light so that objects have some three-dimensionality, but it's not a light we really can control. But as soon as we create a light, jit.gl.light, in our scene, now we gain much more control over the lighting. And so you can see how this is exactly like a film or television set. We have a camera, we have objects on the stage, our grid shapes, and now we're setting up some lights. So the first type of light I want to talk about is at type point. A point light is like a bare light bulb. It exists at a certain location and radiates light in all directions from that location. So let's put it right in the center of our scene, position 0, 0, 0. And we can see immediately something has changed. Now our cubes are dark and only the faces facing the center are illuminated. Let's zoom in and really see what's happening there. All right, so I could see my light source is located between the two cubes. And one of the things I like to do, because it really helps visualize where the light is I like to attach an object to the light to help me see it. And I use a new object for this, an object we haven't seen before, which is just jit.gl.plato. At polymode 1,1, so drawn as an outline, and at scale, make it nice and small, 0.3, 0.3, 0.3, and that will just put a little pyramid where the light is located. I'm going to change my look at to be the center so we can just look right at that light. So there is a jit.gl.plato showing me where my light is. So if I were to hook up a attrui to both of these, and I would want to move around my light marker and my light together so I could really see the location of this light I've created. It's very, very helpful in having a sense of where your light source is. But of course you're not going to want that all of the time. So there's an attribute called enable, and if you uncheck enable, this Plato disappears. Our light is still there. We've just removed its marker because we might not want to see, probably don't want to see its marker in the actual scene. But if we kind of lose track of where the light is, we turn it back on and we see, oh, there it is. I have a little way of seeing where the light is. Also, lights can, of course, have color, but it's a different message than we're used to. The light color message is called diffuse, and by changing the diffuse color, that changes the color of the light. And then you can see the reflectiveness of the light still looks white, so there's an additional color which is called the specular, which allows you to change that sort of reflected or bright, shiny color of the light to actually a different color. It's not quite a realistic thing that these can be different, but it does give you some nice creative freedom. So see, my reflected bit is yellow, while my diffuse area of the light is more of a salmon tone. So this lets you really, in a very fine way. And of course, I'm using attruis here, and this is something that presented a little bit of confusion in the past. I'm using attruis because I want to change things quickly and see the results quickly. But of course, I'm going to need to use load bang or typed in attributes if I want these things to stay in my patch. Attruis do not save with the patch. So if I want my Plato to default to disabled, I'm going to need to type in here at enable 0. That means as soon as my patch is loaded, the Plato is not enabled, and I have to specifically click to enable it. Similarly, if I like these colors, I'll put at diffuse and at specular to set them. That specular yellow is a bit aggressive. And then always, and you should do this in your own work, always take a moment to tidy up your objects. So this object is a little bit hard to read, I find. So I'm just changing the object width so that I can really clearly see everything that's happening inside it. And sometimes you can't make it perfect, but you can make it better, more readable. All right, so moving on from lighting. Oh, I'm gonna just take the edge off of this yellow. There we go. Very nice. I want to move on to really the main part, the bulk of what we're going to look at today, which is the poly-tilde object. The poly-tilde object is very powerful, and probably many of you have been thinking, based on the last tutorials, my gosh, how many of these jit.gl.grid shapes am I going to have to make? I mean, what if I wanted to really make a city or a landscape or a puzzle or a game space? I would have to just keep making these jit.gl.grid shapes, and the screen would become entirely messy and unreadable. And that's absolutely true. That's what would happen, except there are a couple of ways where we can make multiples of objects without having to explicitly create another one on the screen. There's two ways, and I'm going to show you one way in this tutorial. So for those of you who are not in the class and are following this on the internet, you should note that the more current way to do what I'm about to show is with the jit.gl.multiple object. Jit.gl.multiple is a very powerful way of creating multiple objects in a space, and it requires knowledge and sort of conceptual understanding of the jit.matrix object. And since I haven't covered jit.matrix in these tutorials yet, I'm not going to go the route of jit.gl.multiple because it just requires that the matrix be studied first. So it will happen later in the semester, but for now, we're going to look at poly-tilde as the way to create multiples within a space. So to begin with, when we're working with a poly-tilde, it's important to understand that we're working with a separate max patcher, a totally separate max file. So the thing that you want to make multiples of, let's in this case make it of our cube, we take it and we cut it, and we go back to our project window, make a new file in our project, and we'll call it object underscore poly. Save it. And that creates a totally separate max patcher, which we've named object poly. And see, it appears here in our list of patchers, object poly.maxpat. And into that, we paste in whatever we want to be multiplied several times. So this is what we want. The other thing we're going to want to be multiplied in here is a jit.nm.drive. Change my font to Monaco. And zoom in on my work a bit. And taking these few extra seconds to change the font, to zoom in on the work, this is really important stuff. So our jit.gl.grid shape with default lighting enable 1, smooth shading 1, dimensions 100 by 100, shape cube. I'm not going to give it a default position. Just have it default to the center. So remember, what we're doing here is we're creating a new patcher that contains the things that we want to make multiples of. All right, if you need a moment to process that, you want to stop and really wrap your head around what just happened, maybe review it. We've created a new max patcher, and we've placed in it the things that we want to make multiples of. And let me just quickly show you where we're headed with this. I'm going to drag this screen over from my other screen. With one poly-tilde, I can make all 5 of these objects that you see here. But in order to do that, I have to take everything that I want to multiply and put it inside this new patch. And then, something we haven't seen before, a new object is the in object. we're going to create 3 inlets to the object. One, we're going to connect directly to the object itself. Another one, in 2, we're going to connect to our anim drive. And a third, in 3, will connect to our material. So this is the patch that's going to become our poly tilde. It's going to become the thing that we can then make as many copies of as we want. So we save it, close it, and then back here in our main patch that we've been working in, we say poly tilde then the name of our poly file that we just made, which was object_poly, and then how many of them we want. Let's make 10 of them. And there are the 10 cubes. And if we double click this poly tilde object poly, we see the patch we just made. But there's one very important difference. See here at the top it says object_poly 1, meaning we're not looking at everything. We're just seeing one of the 10 copies of this we just made. And note how we had inlets, in 1, in 2, in 3. If we look at the poly tilde object, it has 3 inlets. These are the 3 inlets we have created. Inlet 1, where we can talk to the grid shape, inlet 2, where we can talk to the anim drive, and inlet 3, where we can talk to the material. So now we have 10 cubes, and we can address them all individually. And the message to address them individually is the target message. So if I want to talk to cube 1, I say target 1. And I send that message into any inlet of my poly tilde. And now any further messages I send are directly addressed to not all of the cubes, but just cube number 1. My left inlet talks to the grid shape, my middle inlet talks to the anim drive, and my right inlet talks to the material. So for instance, I can, into the middle inlet, say move to 200 in 5 seconds. Again, target 1, I'm addressing cube number 1, move to, and there one of my cubes, one of the 10 cubes, moves into the new position. Let's move it another meter over. And also I'll reposition this light so we can see a bit better what's going on here. And I also have another type of light to show you. We only looked at the point type of light. I'm going to need to also show you the directional light. Maybe not in this tutorial. I can save it. The point light's enough to get started with. So cube number 1, target 1, has been moved to this location. And if I want to target a different cube, I can send the target 2 message and move it somewhere else, like -3. So we're seeing cube number 1, cube number 2, and then 3, 4, 5, 6, 7, 8, 9, 10 are still all stacked together here in the middle. So I can keep going and say target 3. And I'll move target 3 to this location. And so on and so forth. I can keep targeting my cubes and putting them in different places. Target 4, move it up there. And I can keep doing this by hand, but the point is now it's not as messy as it used to be, but it's still a mess. Look at all these message boxes. Isn't there a better way to deal with all of this information. And there is, and this is what polytilde gives us access to. Before I get into that, let me just go over again what it is about these 3 inlets. This is important. I have 3 inlets to my polytilde because I created 3 in objects in object_poly. The first one talks to the grid shape, the second one to the anim drive, the third one to the jit.gl.material. So target 1, GL color 100, which is red, 1001, which is red and opaque, and see only cube number 1 changes color, and that goes in the left inlet because the left inlet is connected directly to the jit.gl. Oh, actually, a color change should go into the right inlet because we changed the color of the material. A message that would go to the left inlet would be like, for instance, rotate X, Y, Z, 45, 45, 45. That would go into the left inlet, and I've rotated it 45 degrees on all axes. My middle inlet is going to be messages that would go to a jit.anim.drive, like scale to 5.1.1 over 10 seconds. And we can see my object is performing that scale to operation. We sent that to the middle inlet because our middle inlet, our inlet 2, is connected to the jit.anim.drive. It wouldn't have worked to send that message scale to the left inlet because it would have gone straight to the jit.gl.gridshape, bypassing the jit.anim.drive, and so it just wouldn't have been understood. Similarly, we couldn't send it to the right inlet because that would have been a message to the jit.gl.material, and scale to is not a message that jit.gl.material understands. And here I can bring in my image again. Oh, actually I already have it in my patch. And send this texture to the material of object number 1. And we can see that texture is applied. Let's scale this to a different scale so we can see the texture. There. You can see the texture has now been applied to the object. Return it to a cube shape. So what if we want to send a message to all of our objects? Well, that is what we use target 0 for. Target 0 doesn't mean talk to object number 0. Target 0 means talk to all objects. So as soon as we send the target 0 message, now we can texture all the objects, we can rotate all the objects, we can scale to all the objects. So you can see how powerful this is. And of course, this all works in combination with what we already know about our camera, which is that we can lock our look at point, and now we can move the camera around while still looking at the same point. So I can move 10 meters to the right and 20 meters away, and I'm still looking at the center of our world. I'm still looking at 0, 0, 0 because I have lock look 1 on. And so you can start to get very interesting and very dramatic sort of compositions here by moving the lights around, creating multiple lights. There's a limit to the number of lights that you can have in a single world. I don't recall off the top of my head how many it is, but it doesn't make sense to put lights inside your poly tilde. Oh, and by the way, tilde, some of you may not know this, tilde is the key right under the escape key in the upper left-hand corner of the Macintosh keyboard. You hold down Shift and hit that key, and it generates the tilde. Shift and the key underneath escape generates that tilde. And really, you don't need to know that because Max autocompletes. If I type poly, Max already knows I'm talking about poly tilde. So target 0 is very powerful in that it allows us to send a message to all the objects at the same time. So great, but can we take this a step further? We can indeed, and it's actually a very, very exciting step because we know how to make lists using the pack object. And using pack, we could create this list, pack target and some integer. And similarly, we can, I'm going to rotate these. Target 0, rotate them all back to 0 rotation, 111 scale, and I'll leave them in their current positions. So I can pack the message target integer. So I can dynamically change which cube is being targeted. And there's a wonderful object called counter, which counts every time we send it a bang, every time we press the button. So if I want to count from 1 to 10, I say counter space 1 space 10. And I'll put that into, we'll put a number box so we can see the count, and put that into the right inlet of this pack. And so now we're able to change which target with each click of a button. All right, so stop for a minute, make sure you have this built, make sure you understand this, because this is the next big conceptual leap we're going to take. Take a look what happens when I click the button. It goes 1, and that's packed with the word target to create the message target 1, which is sent to our poly. So right now, object 1 is being targeted. When I click it again, now object 2 is being targeted. I click it again, object 3 is being targeted, 4, 5, 6, 7, 8, 9, 10. So for instance, let's combine this with what we already know. Pack move to, and we'll just have it move to a random location. So, number 1 moves randomly there. Number 2 moves randomly there. Number 3 moves randomly there. 4 there. 5 there. Let's zoom in on this a bit and light it a little bit better. Number 6, number 7, I'll zoom out to 15 meters. Let's see what we're doing here. So before, if you recall, we needed a separate random structure for each one of our objects. But now we just build this once, and it's randomizing. Each time we click the button, it's generating a new random location and sending that random location to a different target. And actually, I should point out that I've actually misspelled this in terms of max. Because max is a right-to-left language, we want to make sure we're setting the target before we're actually sending the random values. So really what this should look like is this. That may not seem like a big difference to you, but it actually is. And again, it doesn't matter what inlet the target message goes in, so it's fine to connect the target message to the rightmost inlet. Because max is right to left, the first thing we want to do is generate the count and set the target. The second thing we want to do is generate this random location. The third thing we want to do is generate this one, and the fourth thing we want to do is generate that one. So this is correctly spelled, if you will, in max, from right to left. The things we want to do first are on the right, the things we want to do last are on the left. And so we can create a random position, and the counter counts from 1 to 10 and then it starts over. So we're back on number 3, and now we're randomizing the position of number 4, randomizing the position of number 5, number 6, number 7, number 8, number 9, number 10. And as we've talked about in class before, but haven't addressed in the tutorials, this random 5 gives us a number between 0 and 4 meters in the positive direction. So you can see everything, all our objects are now to the right of the center. If we want to offset this, we can simply use the minus object and subtract 2. So now our objects are going to be placed between negative 2 meters and positive 2 meters. They'll be clustered around the center rather than clustered into the upper right quadrant. And then if I want to suddenly do something to all the objects, I can still, into a message, type target 0, for instance, scale to 0.5, 0.5, 0.5 in 1 second. And see, I'm using that comma that I showed you before to send 2 messages in sequence. And now suddenly, watch all of the objects. They're just going to shrink down to the new scale because I'm targeting 0. But if I click this button, it's going to then take me back to, this counter is at 10, so the next number is going to be 1. It's going to move only cube 1 again, then cube 2, then cube 3, then cube 4, then cube 5. So you could see how much more powerful this is to be working in the poly and how much neater this patch is. I've got very, very little stuff on the screen to control the locations of 10 different objects. Let's take a look at one more thing, which would be if we wanted to randomize the color of these objects. I can actually use the same counter. I don't need to repeat this. And I can use the same sort of random structure here. Except now, my math needs to be different because I want to generate a different range. I want to generate a range from 0, between 0 and 1 for red, green, and blue. So I'm generating a random number between 0 and 4, then dividing it by 4 to create the possible values of 0, 0.25, 0.5, 0.75, and 1. those are the 5 different possible values. I'm going to send color to the texture, the material inlet. So now each of my cubes gets a random color each time I click the button. And notice I'm recycling this counter and target, because when I click this button, and here's again where color coding comes in handy. When I click this button, only the things that it is connected to are triggered. So the counter is triggered, and then this random is triggered, and this random, and this random. So all the randoms are triggered from this button to change the colors. Whereas this button uses the same counter. It's going to the next cube it affects is going to be cube number 4, but now it's changing the move to. Okay, so I want to move on to one more concept, and then we're done for this tutorial, which is let me just show you one other thing in terms of neatening up. And I did show you this in class, but we haven't done it in a tutorial yet. Once things start to get messy and crowded like this, you can tuck stuff away into what are called subpatchers. So I'm never going to need to look at this set of objects again. It's done. It's doing what it's doing. I'm happy with it. It's my random positioner. So I can say edit, encapsulate, and it just sticks it into this P object, and I'll call it rand position. And now it's tucked away inside there. So if I double click it, I can still see it. There it is. I can still see it. I can still edit it. That's fine. But it's inside of this subpatcher. And I can do the same here. Highlight what I want to encapsulate. Say edit, encapsulate, P rand color. And then that's just stuck inside there. Rand color has everything that I made inside of it. So now you see how much neater still the patch is. So that's great. Every time we click a button, we get a new color. Every time we click the button, we get a new position. But what if we wanted to even automate that process so we could have all the cubes change position with the click of a button? Well, there's a great object with kind of a questionable name, Uzi. What Uzi does is, for instance, Uzi 10, when I send one button press in, it sends 10 button presses out as fast as possible. So if I just take an Uzi and connect it to my button and connect another button to the Uzi, it's gonna, when I click this button, Uzi will click this button 10 times as fast as possible, causing all of the cubes to adopt new positions. Now I think you can see we're getting someplace interesting. Let's zoom back in on this a touch. Make that lighting a bit more dramatic. Similarly, with color changes, I can change all 10 colors at the same time. And the wonderful thing is, let's say I suddenly want there to be 20 objects. That's fine. I change to 20 objects, and now there's 20 objects. I change my counter to 20. I change my Uzis to 20. And that's it. I've just doubled the number of objects with a few clicks. So one final thing I'm going to show you, which is a time saver. Counter is wonderful, and we really like counter. It's very useful in a lot of situations. It's also replaced by the right outlet of Uzi. The right outlet of Uzi, in fact, is a counter. So we can take the right outlet of Uzi and put it directly into the pack. The left outlet of Uzi is a bang, so we actually don't need another button there. So we're further simplifying everything. This is going to function exactly the same way. random positions, random colors. There's one other object that I wanted to get to, two other objects that I wanted to get to today. One is actually a very simple object that is the tempo object, which some of you are going to be wanting to use this software to make music videos or maybe sort of VJ software that could be used in a club where there's a beat. And tempo is a nice object for doing that because tempo takes a toggle to turn on and just generates 16th notes at the tempo chosen. So 120 beats per minute, it's going to be outputting 16th notes at 120 beats per minute when I turn it on. Just to see it, I'll knock it down to 60 beats per minute so you can see. Right, so it's like Uzi, except instead of sending the bangs as fast as possible, it sends them in a regular rhythm. So this could be connected to a counter. And it's going to change the color of the cubes according to a beat, according to a rhythm, 16th notes at 60 beats per minute. It might be more visible if we then now crank it up to 120 beats per minute. So it's a rhythmic counter. And so this is really great for working with music. You can simply set this to be the same beats per minute as the music you're working with. And there's also a way to, it defaults to 16th notes. It doesn't have to be 16th notes. Also, this might be obvious, but you can, instead of counting through your targets, you can certainly also randomly choose your target just by replacing counter with the random object. We have 20 objects now, so I'd say random 20. And then we do want to add 1, because remember, random 20 is going to generate a value between 0 and 19. And remember, 0 means change all objects. So what we want is a range from 1 to 20. So we can use the plus object. Plus space 1 just adds 1. And now we're working through the 20 objects randomly, using the random object instead of the counter object. And one final note, we're going to deal more with this later, but for the time being, I just want to introduce it in the sense that randomness actually has its limits. Randomness isn't always all that interesting. A lot of times what we want to do is something that has a non-random pattern, where each of these can be different, but not random. So let's take all the randomness out of this. And for instance, what we can do is position all these objects in space based on their number. So right here we know coming out of this we have a number between 1 and 20. So there's a new object called scale. And what we can say to scale is, look, we know we're getting a series of numbers between 1 and 20. Let's have them correspond to a series of numbers between negative 10 and 10. So in other words, when 1 comes in, negative 10 comes out. When 20 comes in, 10 comes out. So we're scaling the input range to an output range. And then we can say move to, oh, actually we'll need a pack here. Pack move to your new location in 2 seconds. move 2 goes to the center inlet. And now they're all organized in a line. Why is that? Well, when we clicked Uzi, it spat out 20 bangs. We didn't use them. It also spat out as fast as possible the numbers 1 through 20. So each time it spat out a number, it set the target and then scaled the input value to the output value. So when the target was 1, the X position became -10. When the target was 10, the X position was 0. When the target was 20, the X position was +10. So we're using scale here to scale an input value series to an output value series. Let's take a look at another example of that. Here, I'm going to say I want object number 1 to be 10 meters tall, and object number 20 to only be 1 meter tall. And I want all of the intermediate objects to be scaled accordingly. Right? Object number 1 is 10 meters tall because when a 1 comes in, a 10 goes out. Object number 20 over here on the right is only 1 meter tall. In fact, object number 20, we could make it 0.1 meters tall. See what that looks like. There. That's even more extreme. So object number 20 is 0.1 meters tall, and then every other object is scaled accordingly. So the scale object is very, very powerful, and of course can be applied to any aspect for instance, jail color. Which goes in the right inlet because that's where our material object is. And in this case, we're going to scale incoming values of 1 to 20 to object 1 is going to be bright red, and object 1 is going to be black, and object 20 is going to be bright red. So scale the values 1 through 20 to 0 to 1, black to red. That didn't work. Oh, I must have put it in the green inlet. There, put it in the red inlet. There we go. Yep, that's pretty good. Oh, the orange must come from the specularity of the light. So now we've got multiple colors interacting here because we've got the coloration of the light interacting with the coloration of the objects. If I set this back to a white light. That specularity is still causing it to wash out a bit. There, if I move the light over, we can see that redness. All right, so that's an hour, which is longer than I wanted to go, but I've covered everything that I wanted to, some of it rather quickly, so we'll be digging a bit more into some of these topics in a later tutorial. But I sincerely hope that this has been useful for you, and feel free to email me with questions, and I look forward to seeing you in the next tutorial. Thanks a lot. Bye-bye.